Again, I'm Ioana, and I will be moderating the talks for today. The first one will be offered by Kim Nilsson, who is the CEO at Pivigo, and she will share with us her lessons from completing 100 data science projects. Everyone, please welcome Kim.
Thank you very much. Thank you all for coming on a Friday morning to listen to this talk. And thank you again to Big Data Week for the wonderful flowers this morning that they surprised me with. It happens to be my 10-year wedding anniversary today. And I was going to fly off with my husband, and I'm still going to fly off with my husband this afternoon. So I will only be here until about 12 o'clock. So if you want to catch me for any questions afterwards, please do make sure to do that before 12, and then I will run off. But thank you again for the wonderful flowers. But let's talk data science, because that's what we're here about and that's what we're all excited about. And so I actually don't think I need to tell you much about the data science industry, because you are here because you are interested in it. And you all know that it is a large market, and it's a market that's growing very rapidly, where there's a lot of interest in doing big data projects. And of course, this demand and this increasing demand for data science projects means that we also have this lack of talent that I'm sure, again, you will have heard about these reports saying that we need hundreds of thousands of more people working in analytics jobs in the future. So there is a great demand in the market as a whole. And then if we look at the reasons why there is this demand, I think we all know that there are a lot of case studies and a lot of reasons why, as organizations, we should be doing data science. I will come back to these case studies a bit later, but just to give a flavor of it, one organization we worked with selling car parts were interested in price optimization, and in a 5-week project, we were able to deliver a pricing engine that could increase the revenues of this company by £6 million over the next 5 years. So it's clear that there's a lot of value and there's a lot of money to be had in doing data science projects and doing them properly. But sometimes I feel that we neglect also the other element of what data science can do for society. And it's not just about making money. It's also about us having better lives, staying healthy, and understanding how we can just live better lives and take care of our planet. And as an example, again, a case study I'll come back to, we also worked with a startup that wants to help women prevent women getting postnatal diabetes, which I didn't know this, but apparently it's a big problem when you're pregnant, you have a baby. Many women end up with diabetes after the pregnancy, and this is of course a debilitating condition for them, and it's a problem for society as a whole. But even there, data science can help, and I'll come back to that again. So if we know the market is growing, and we know the reasons why we should be doing this, it's both about how we work, how we live, how we stay healthy, then why is not everyone doing it already? And I think there are a few key reasons that we have found working with over 70 organizations to date, and of course talking to many more than that about their data science efforts. There are many key reasons for why they're not yet maybe doing it. Number one is of course access to data. And this is perhaps a problem more in startups and younger organizations, although it's not necessarily only there. Having data in the first place, and then of course having access to it. Even in more experienced organizations, there may be data, but it might be hidden away with different owners, and who may not be very happy to hand that data over to others. So having access to data really is the first hindrance for companies to get started with data. And then where do you start? What is that clear starting point where you can start to look at your data and start to get value from it? And related to that also, what are you asking the right question of your data? We see so many companies that actually they've passed number one, they've got the data, but then they don't know how to get started, and they don't know how to ask the right question, and then they get stuck on that level. If you get past that, well then the next question is, how do you plan your resources? You need people, you need tools, but you also need people to handle those tools. And do you recruit, do you outsource, do you contract, do you get a consultancy in? Any of these decisions can be quite daunting for those who have not previously ever dealt with analytics capabilities and taking them into the organization. And finally, the last problem, and I think this is really the biggest problem in some sense for most organizations to get further down the path of becoming data-driven, is lack of commitment, and specifically lack of commitment from the senior levels of management. I've seen so many organizations where we have what I like to think of as data heroes. We have people, 1 or 2 or 3 individuals in the organization who are fighting the cause of data and who are trying to do little projects, and they're trying to scrape together a budget to do it, but not necessarily succeeding in then taking that to the next stage and convincing management that this is something we need to invest in going forward. So what can you do if you are one of those organizations that's relatively early on? What do you do to become truly data-driven? How do you go from being data curious to being data-driven? And from these circa 100 projects that we have completed with companies to date, I've found that there are 10 steps really to go through in this process of going from being a data innocent into actually being very, very data-driven as an organization. And I wanted to go through that now. So number 1 really is the data. It starts and ends with the data. Do you have data, and how much of it do you have? And it is about volume, but it's not necessarily only about volume. It can also be about complexity of data. So the volume doesn't have to be that big if you instead have very complex data. A regulatory business, for example, that we worked with had only a few megabytes of data, but it was all in very complex legal documents and PDFs where just the analysis of the text itself was so complex that we needed a team of data scientists to work on it for several weeks. So do you have the data? Number 1. And then if you have it, do you have the right quality, and do you have access to it? So is it clean? Is it joined up? Sometimes the first thing the data scientists have to do is to take disparate sets of data and merge them together and make sure that you can connect, say, a customer from one database to another, which is not a problem, but it needs to be done. And access, as I mentioned earlier, can be a problem. There might be different data owners who are holding on to their data and who are afraid to give it up. And so you need to make sure that it is possible to put it all together into analysis before you get started. Now, once you get past the data stage, really it is about the question. What question do you want your data to answer for you? And this should always come before anything else. Any other conversation around what the project should be is about the question. You want your data to solve a business problem. And it should be the one question that is keeping the CEO or the CMO or the CFO awake at night. The one thing that if you could fix that, it would be the game changer for your business. And then the question is, how do we solve that question with data? It's the wrong idea to start with the data and then think, let's see what we get from it. Start with a question and then think, how can the data solve it? So the importance is in the question. And then the 4th step really is management support. Making sure that senior levels of management are comfortable with getting started with data. Making sure that they understand that data science is R&D, which means that some projects will fail and others will be extremely successful. But managing those expectations and making sure that they understand that it's worth investing in this, what return you might see at the end of it, and also that there is a risk of failure. Getting that support really is key to getting started. So for me, steps 1 to 4 are really about setting the groundwork to start working with data. And then the next 3 steps are about actually getting started, actually implementing it. Now, you might think that number 5 is getting data scientists in, but not yet. Hold your horses. Before we get the data people in, let's look at the IT expertise within the organization. Because you need to have, first of all, the IT people on board from the start so that they are able to pull the data together, as I said, get access to it, make sure it's available to the data scientists, and make sure that it's all joined up, as I said, and make sure that the tools are in place. And also, of course, get them on board so that once you get a solution at the end, they are ready and they are prepared to implement that solution into your systems. The last thing you want is to have a fantastic solution, algorithm, whatever it might be, lying about not being implemented. So get IT on board. And then, even one more step before we get the data scientists in, have a think around tools and technologies. So we've seen situations also where you ask the organization, do you have a preference on what tools to use? And they'll just say, no, I don't really know what data scientists use. They can use whatever they want. Which, by the way, will make the data scientists very, very happy because they love free hands to use whatever they want. But you might end up in a situation where, say, they've written a solution in R, but actually you needed it in Python to implement it, which means that you're now doubling up the work and you now have to replicate that solution again into a new language, which might leave, again, that sort of foul taste around, was this really worth it? So just having that little think beforehand, are there any particular constraints in implementation that we should think about before we start? And again, if you don't have those preferences, perfectly fine. Your data scientists will be very happy to get started on their own. So now we're finally ready to bring in the data scientists. And of course, at this stage, you have that question that I mentioned earlier. Do you hire? Do you bring in contractors? Do you bring in consultants? How do you want to get those people in? And what is the right set of skills that you need? I'll come back to that in a minute, but it is a difficult choice, and every choice you make will have benefits and disadvantages. So 1 to 4 was set up, and 5 to 7 are really about getting started, getting your hands dirty. The final 3 steps then are really about ingraining it into the organization and trying to build that truly data-driven organization. And to do that, and hopefully you can do that after having done your first proof of concept, etc., is budget. So at this point, you can probably get to this point with a small discretionary budget, as I said, scraping together a few pots of money here and there. But at this point, if you want to take the organization to the next level, you need that budget. So a significant budget, I'm not going to say how much because it depends on your organization, but you need a significant budget to continue and continue this research and development that it is. And then the final 2 steps are really about communication. So number 9 is feedback and communication. You need to have constant feedback and constant communication flowing between the data scientists and the rest of the organization. Both ways. Both ways are very important. So the data scientists have to be able to explain their models to the rest of the organization, to the people on the factory floor. They have to explain what they're doing. They have to explain the purpose of it. They have to explain how it works. And they have to ask for feedback. And then the people on the factory floor, for example, need to be able to come back and say, well, actually, this model really doesn't work. Why should I sell red shoes on a Tuesday? It doesn't make any sense to me. There might be something wrong with your model. So that constant flow of communication is really, really important. And especially because that then leads to the final step, which is the buy-in, which is the cultural shift within your organization, where everyone buys into this vision that we are now a data-driven organization, we are digital, everything we do, we monitor, we measure, and we take the outcome and we deliver something great for our customers. So really that's the 10 steps. And of course, a couple of notes on that is it may look like a linear process. It's definitely not. And you might end up skipping a few steps. You might go backwards. You might do it in circles. You might start and then stop and then take a break and start again. And it's a process that typically takes years. So don't despair if you're only a few months into it and you feel like you haven't gotten very far. So it's not a linear process and it takes time. But what we have found is that if you really want your organization to be that data star, that truly data-driven organization, you will at some point need to go through all of these steps. So then coming back to our experiences, having now delivered over 100 projects to over 70 organizations, again, coming back to some of just the key advice that we have found on how to run successful projects. And number 1 is about agility. So please do not embark on a 6-month transformational program that's going to transform everything, because you will almost certainly fail. We feel that any program like that can really be broken down into much smaller pieces. 5-week, 6-week, 7-week projects where you can test a hypothesis and see what comes out of it. At the end of it, you evaluate and you decide, do we want to continue with this? Or actually, did something else come up in that project that sounds more interesting that we should pursue instead? So being agile in how you run your data science projects is very important to minimize the risk, to minimize the cost of that potential failure that can happen in any R&D project. And associated with that is the start small bit. So if it is your first project, start with something small, some low-hanging fruit, something easy where you really think you can deliver something. And then take that success and build on it. Make sure you have the right skills. Now, of course, this is about technical skills, and I don't think I need to talk about what technical skills you need as a data scientist. Two things I want to mention on that. Number one, data science is a team sport. So you want to make sure that you have access to a wide range of data scientists with different skills who complement each other and who can work well together, because you will never find all of those skills in one individual. And the second thing to point out there is the importance of having a communication link between the data scientists and the rest of the company. Many data scientists are very, very happy to work with their models and sit in front of their computers, and not everyone is very, very good at communicating what they're working on. And vice versa, business people may not necessarily be the best at explaining to a very technical person what it is they actually want. So the projects that we see that are most successful are the ones where we have a project manager or a data science manager or someone who can act as a link and who can interpret between these two camps. Expectation management I've touched on in the past in this presentation. So making sure that everyone understands what the risks are and what, of course, the benefits are to go with it. Making sure that everyone understands that data science has the word science in it for a reason. It is R&D and it might fail, but we might also deliver something fantastic, something like a £6 million revenue increase. And convince the skeptics. So there will always be people in your organization who are worried about what data science will do to the organization or, God forbid, to their job. And if they can typically wreck your project if you don't get them on board. So trying to find out who are the ones that are really skeptical about what you're doing. Talk to them, understand their worries, and then explain to them what you're doing and try to get them on board. Try to get them involved in the project. That way you can win them over and you can avoid those roadblocks in the future. So I am running short on time, I think. No, I've got a few more minutes. So let me talk you through briefly those two case studies I mentioned in the beginning, and examples of where data science can work really well in actually just 5 weeks of work. So the car parts company I mentioned, Parts Alliance, it's an SME business based in the north of England. They came to us wondering, can we increase our revenue by just deciding better on the spot what the price should be that we sell at? So they asked us for a pricing engine that could look at updating prices immediately. And in 5 weeks, we had 4 data scientists working on this project. They were looking at about 20 million sales transactions from the past. And they created a machine learning algorithm, a pricing engine that, as I said, could deliver £6 million sales increase, sales revenue through just optimizing these sales. This is, of course, very, very significant for a relatively small business, and a fantastic example of what you can do, the sort of low-hanging fruit that is in pretty much any organization, anywhere. The other one that I mentioned, the diabetes case, a startup called Watch Out Diabetes. They want to develop a diabetic nurse. So this is around, as I mentioned, you've come out of pregnancy, you've had your baby, there is then a risk that you might develop postnatal diabetes. But it can actually be very easily prevented if you just eat the right things. So they wanted to come up with an app that could give this personalized lifestyle and nutritional advice, and that could prevent diabetes. Again, 5 weeks, team of 4 who created this recommendation engine that could then give these personalized meal plans, including shopping lists, based on the individual who's using the app, what their preferences are, etc. And this algorithm is now also being integrated. So a perfect example of where data can help society and not just make more money. So to conclude then, I think it's clear that absolutely data science and AI and machine learning will touch every industry. It can and it will change every industry that we are working in. So it's just a question of getting started sooner rather than later. If you've got the right team and if you've got a good question, then that's what's going to give you the advantage over your competitors. So I guess the question I really want to leave you with today is, what question do you want your data to answer for you? So that's it for me, and I think we've got time for a few questions. Thank you.
Yeah, I just wanted to ask you, in terms of the pricing engine that you talked about, how is that going to be impacted by GDPR coming up next year? Because I would think if you give differentiated prices to differentiated customers, things like that, that might have an effect and an impact. Did you or the organization that you did this for had any idea on that, had a strategy around that?
It did not come up in the project itself. So the project we did now about 6 months ago. So it was a little bit before GDPR came on the agenda. I'm not a GDPR expert myself, although my understanding about GDPR was more around marketing. That there was, for example, not signing people up to marketing lists without asking their permission, etc. I honestly don't know. I'm not a GDPR expert. But yeah.
Okay, no worries. Thank you.
Questions here?
Talking about some of the steps earlier in your process, particularly around IT support and making sure you've got the technologies in place. And then that with the pitfalls you mentioned at the end. So how would you approach those two steps while remaining relatively agile and convincing everyone to come along with the process?
So I think the point I was trying to make was more around just making sure that they're on board and that they dedicate resources for the data science team and for the data science project, and that they are aware of what's going on and that they are embracing the change that's coming. A case study, another very brief case study, another organization we worked with where we had delivered a fantastic solution, another multi-million-pound potential revenue increase. And in the end, the CIO blocked it because just said, no, I don't think it's going to work in my organization. The CEO loved it, but the CIO blocked it. And that was a case of, oh, well, if we just brought that person on board before, maybe we could have avoided that. But again, there might be one of those skeptical things there. How is it going to affect my job if we start to do all these things, etc. Cultural shifts within organizations are always going to be difficult. And the sooner you start working on it, the easier it is. So I think that was more around the point I was trying to make with that. There's a lady behind.
Hi. I wanted to ask you, from your experience of these data science projects, what do you think is the biggest obstacle to initiating and getting that buy-in to the project? Is it the human factor of people signing off the projects, or is it the technical availability of the data?
I think ultimately it is the human factor. We talk to a lot of organizations that we know they have the data, we know there are interesting projects there, but in the end, business as usual is always easier. Doing nothing is always easier in some sense than trying something new. And this is new for most organizations. They don't know how to do it. They don't know what they might get out of it in the end, so it's quite risky. The person that signs off on it in the first place, if the thing fails, then they might feel that their head is on the line. So it's a risky thing. You've never tried before. You don't know what you're going to get from it. And if no one else seems to be doing anything else either, then it's a bit of a game of chicken. And it's so much easier to do nothing. So I think in most cases, the problem really is taking the plunge and going ahead and trying it out. And again, that's why we're always talking about start small, try something small, just do something. And then you can build on that as you go forward.
Just getting back to the example you gave of the red shoes on a Tuesday thing, and
Yeah.
I guess the buy-in and the scepticism that might arise. Do you think there's an importance, in some industries at least, of capturing the beliefs and intuitions of those people at the coalface? So the bottom end of the pay scale, the people who are doing the work that's probably going to be most affected by changes to process and so on and so forth, and potentially using those intuitions and beliefs as initial hypotheses, and being able to say to them, yes, you actually are right, or no, you're not, and this is why, to improve the buy-in and improve the likelihood of actually being able to implement the changes that come from the work that you've done.
Yeah, yeah, absolutely. And maybe that's a little bit of criticism towards any data scientist in the room, is that we tend to believe in our models, right? If the model says X, then X is right. If the model says red shoes on a Tuesday, it has to be red shoes on a Tuesday. And sometimes we are not skeptical enough ourselves, in some sense, to go back and look at, well, what made that happen, and is it possible that we've made a mistake? Does it make sense? And so I do think that flow of communication is extremely important. I've seen some fantastic examples of organizations where they take their data scientists and they say, well, once a month or twice a month, you actually have to deliver our service. If that is, we work with Royal Mail. At Royal Mail, at least one day a year, you have to deliver mail. You have to actually physically go out and deliver mail. And there was another organization, it was a logistics firm, I can't remember what, where again, they would put their people in the logistics center one day a week, or one day a month or something, just to see what it's like and to understand it. And that's very important, absolutely, yeah.
In terms of where the data analysis fits within the organization, do you see more value having like a standalone data analysis team versus sort of having sort of analysts sit with the business in terms?
So that is a very slightly related question. Very interesting. So I actually attended a talk with Nesta, the think tank, about a year ago now, I think, or a year and a half, where they had done some studies around how do organizations place their data scientists. And indeed, they found that some of them place them in, shall we say, a task force where they are 100% together and they only sit with each other and then occasionally go out and have meetings. And then there are other organizations where they are completely dispersed. So your data scientist will be immersed into business units. And I think their report, and probably my understanding as well, is that both are fine. There are pros and cons with either. You can't say that necessarily that one is better than the other. Data scientists do need to be in touch with the organization. They also do need to share with each other and share the experiences, share the learning. As a data scientist, you're constantly learning new tools, new techniques. Shall we try this? Shall we try that? So whichever constellation you choose, you have to make sure that you work against the not so good things about that constellation. So if they are dispersed, for example, make sure they come together ideally once a day or at least a couple of times a week to meet, and vice versa. If they are in their own task force, make sure they go out into the organization regularly. It's just being aware of the pros and cons and making sure that you mitigate the downsides. Okay, one more. There's one here.
Hi, my name is Akshat. My question is, you talked about the steps, basically how to check if you are data ready, which means like having data first and then defining the question. It's often seen generally with the business people or the senior team members that they're more concerned about the questions first than the data, without thinking if that could be answered with the data they have. So what would you recommend, that data should drive the questions, or it should be the other way around?
So as I said, I think actually the questions should come first in some sense. And then, of course, again, there's a bit of expectation management to first go to the company and say, what questions do you want? And then they say this, this, and this, and that. And then you go, oops, actually, we can't do that. Then again, you get a bad result. So, of course, there's a little bit of doing both. I actually, when we go into companies, and we sometimes do these sort of set up projects and set up consultancy, we will typically do the two in parallel. So we will do a data audit on one side and look at what have they got and what can we do with it. And then in parallel, talk to the business people and find out just what their questions are. And then we can bring that together and we can say, okay, based on those questions and the data we have, what can we do right now? And then maybe also, well, to answer the questions we can't answer right now, what data do we need to collect in the future? But ultimately, I do think you have to start with a question and then see what the data can do. Because doing it the other way around is a recipe for failure. You'll get something, but it probably won't be the one thing that's really going to answer the questions that senior management have. And then ultimately that means they'll say, well, why should we invest in this? It's not really bringing anything significant. So I think question first, but of course being aware of what data you have. Okay, thank you.